All right, this is team project number 2 for group number 19. Our experiment was to test the reliability of DC motors. In order to perform the experiment, we used 3 brands of DC motors and a sample size of 50 motors for each brand. Every motor was tested until failure by sending a current that spins the motor 90 degrees in one direction and then alternating the current to rotate the motor 180 degrees in the opposite direction. After all the motors were tested, the brand with the least motor failures was deemed most reliable. Using Microsoft Excel, we are able to tabulize the results in this format. Here's the results for brand number 1, Techno Drives. Here's brand number 2, LSK. And here's the third and final brand, Baldor. From the results, we found that Baldor was the most reliable brand, as it had the least number of failures, and using the equation above, we found the probability of success, or the reliability probability, which Baldor had a reliability probability of 0.9 or 90%. Technodrive, we found, had the most failures, so it can be considered the least reliable. It had a success probability of 0.82 or 82%. Overall, these results can be misleading because of the small sample size for each brand, but for the purpose of our experiment and showing the statistical analysis of data, this experiment shows us an effective approach of finding a motor's reliability.
When applying the results of this experiment to the real world, it can be seen how significant it is to determine the reliability of these DC motors. For example, looking at a smaller scale, these DC motors are utilized by engineering students here in the university in order to power their boats for the Ganor race. Now seen from a larger scale, DC motors are utilized in various forms of transportation, such as aircrafts for their fuel flow control and boats for their power poles. If these DC motors are not tested well for their reliability, it can result in unnecessary accidents that could have easily been avoided with the proper data. By gathering this data on the reliability of these motors, we can improve the effectiveness of our machines as well as the safety of them, making it better for the engineering field all around.
In our experiment, we were trying to test reliability of different brands of different motors, and we would connect those by a probability, which would be our statistical topic when we were talking about our data and our conclusion. And so by dividing the number of failing motors by the number of total motors, as you can see by the probability formula, we could find the reliability probability of each of those brands of motors. And in the end, we would compare those different numbers of the probability reliability to see in the end which brand of motors is more reliable to use. And when it comes to relation to engineering, testing for the reliability of a product is very important because it would increase the safety of that product and it would make sure that it's more reliable for use in the real world. And it would make sure there wouldn't be as much faulty planes or endangerment of others when flying. And the engineers who don't test are leaving those motors with unknown risks able to happen.